Okay, we are continuing with January 2011. We left off at number 16. If you were going to solve this by completing the square, they want to know what one of your interim steps would be. So since they set it up this way, you want to pull your x's to one side. Let's subtract the 6x from one side. And let's move the 2 to the other side since they have it equal to something. Let's move your 2 over. Now, give yourself enough room so that you can find a term that we can plug in here to complete this perfect square. This is a minus 2. But because we added to the left side, we also have to add it to the right side. Now, half of b. b is negative 6. So this would be negative 3. You write it x minus 3. And you square it. X minus 3, 3 squared is 9. Here and here. This piece right here is your x minus 3 squared. You have completed that square. And this becomes 7. So they want to know what an interim step would be. So before we moved everything to one side, we ended up here. Number 17. 3 marbles are to be drawn at random without replacement, which means I'm not going to replace them back into the bag. The bag contains 15 red, 10 blue, 5 whites. Altogether, I have 30 marbles. Which expression can be used to calculate probability? Probability is part over whole of getting 2 reds and 1 white. Now, the bottom number, notice the only difference between these are a P and a C. If order matters, then you're a permutation. If order does not matter, then you're a combination. And it doesn't matter what order we pick these up in, so we're looking at C's. So we're going to eliminate anything that throws a P at us. Therefore, there's only one left, and that's 1. But if you were to work this out, the bottom number says, out of my 30 marbles, give me any 3. Remember, probability is part over whole. The top says, I want 2 reds. I have 15 to choose from in any combination, times it by 1 white. I have 5 to choose from in any combination. So there's your choice 1. Number 18. Number 18 has a negative exponent. Remember the effect of a negative exponent. It does not cause your answer to become negative. 2 to the negative 1. Put it in your calculator. You get 0.5. If you convert it to a fraction, you get 1/2. You can see that it took its reciprocal. See the reciprocal? A negative exponent takes the reciprocal to the positive power. So x to the negative 2/5, that negative is going to flip this over. Now, 2/5 has an exponent up here, the one that it's raised to, keep like that. And this one under the denominator is the one from the radical. It's the index of the radical. So we're looking at choice 4. Something that might help is to pick a value of x. Like just let x equal 4. And plug in 4 to the negative 2/5. And then come down here and do this with your 4. And they should end up with the same value. That's another way if you're having trouble with your negatives. Okay, number 19. Number 19 asked 4 different graphs, and I don't think I'm going to get them all on the same page. So I'm just going to bring them down here for a second. Okay. It says a certain stock costs $180 per share. I'm just pulling out the information I need. Each month thereafter, the share of the stock decreased by 1/3. If X represents time, X is time, and Y represents the cost of the stock, you want to find which graph best represents the share over 5 months. They all use 5 months out here, so we're good for that. Now, because you're taking 1/3 of what is left, not the same amount each time, you're not getting a fixed curve. You're getting an exponential curve because you're taking 1/3 of whatever is left. So say you started out with 180. You took 1/3 of that. 1/3 of 180, even divided by 3, is 60. If I take away 60, then I'm at 120. Now, take 1/3 of 120. 1/3 of 120 is 40. If I take away 40, I'm now at 80. These are ones you might want to look for. At the 0, you're 180. At the 1, 120. At the 2, 80. So, if you go through this, you're going to look for at the 2, let's look at this one. At the 0, you have 180. At the 1, you have 120. At the 2, you have 80. So there's your choice. This one takes a little bit too steep in number 4. A little bit too steep, and it doesn't match up to what we assumed that this would be. Okay, number 20. Number 20 gives us a right triangle. And the measure of JT is 12. The measure of JN is 6. And there's your 90-degree angle. Okay, it wants to know what is the value of the cotangent of J. J is your reference angle. This side, opposite the right angle, is always the hypotenuse. Opposite this angle is your opposite side, and next to it is your adjacent side. So you have an adjacent, and you have an opposite, and you have a hypotenuse. Now, the ones we don't have is an opposite. So we're going to work with anything that uses adjacent and hypotenuse. You might need to find your missing side since your cotangent is dealing with your reciprocal of your tangent. If your tangent is opposite over adjacent, then your cotangent is adjacent over opposite. But you don't have an opposite. So to find the missing side, you do Pythagorean's theorem. Do that first. 12 squared equals 6 squared plus, we'll call it b squared. And you can subtract these. Take the square root. Notice they don't have anything that has 108. You have to separate this into your perfect square times your not so perfect square. So now replace this. And now do your cotangent. Adjacent, which is your 6, over your opposite. And reduce. So out comes the 6's. Remember when you cancel out this factor, there's a 1 left on top. Now there's nowhere that says this one, so you're going to have to rationalize your denominator. Multiply the numerator and the denominator by radical 3. And it turns out to be twice 1. You had to go through this little interim step first to find the missing side. Remember your SOHCAHTOA, that helps too. And also remember to keep track of your reference angle.
35406.
Okay, and number 21, here's a question that asks the sum of the roots and the product of the roots. And these are those two little formulas. Your sum of the roots, negative b over a. Your product of the roots, c over a. They're your coefficients from your quadratic. Now, for which equations is the sum equal to negative 3 and the product equal to 2? For each one, you're just going to have to go in and write out your pieces. A is 1, B is 2, C is negative 3. I would first go to the product because that has the effect of C. Anything with a negative in here, since all your A's are positive, anything with a negative is not going to work in here. Now that only eliminates one, but at least that kind of helps. So the B, since your B is negative, it's going to have to be the opposite. It's going to have to be the one that is positive. And you can see, here's two negative B's, here's one positive. It's got to be the positive one because we're going to put it in with a negative. So I'm going to scoot to this one and try this. So my sum is negative of B over A. There's my negative 3. My product is C over A. Then there's my 2. Reason it out a little bit, or just try them all. Okay, number 22, we're looking at one term, and they want to find the equivalent, which means that we have to rationalize the denominator. Now, when you rationalize this denominator, you multiply by radical 3. Therefore, when you rationalize this denominator, you're going to have to multiply by itself, x plus 2. So pull this over on top. This is one big line. Just pull it over for now. And when you multiply a radical times itself, the radical goes out. If you look at your answers, there's no x plus 2 in your denominators at all. So I can kind of rule out this one and this one. Now I notice that I got rid of my denominator. So I take a look to see there's nothing I can do with my radical, but in this factor, I can factor out a 2, which makes me now have a common factor. And we're left with 2 radical x plus 2. Okay. Number 23, I can't fit the whole thing, so we'll just read the steps. It wants to know which of these functions is sketched. Now, because these are all y equal, you can put these in your calculator. When you put y equals the tangent of x, because this is a trig function, set your mode, and you can leave it in radians, you can leave it in degrees. 180 is the same as pi. I think it's easier to leave it in degrees. And do a zoom trig. That'll help you. You're going to see your tangent go like this. Well, my pen's a little off. So we notice that's certainly not a tangent one. The cotangent is the opposite way. So we notice that's certainly not a cotangent one. Now the secant and the cosecant are your reciprocals. So if you draw your curve in here, this will tell you what's the reciprocal of. This is at your 0. Your 0 is where at 0 is the sine of 0. So therefore, this is the reciprocal of a sine curve. And its reciprocal is a cosecant. You can also put cosecant in like this if you want to graph that. Now you might want to change your window. Be careful because normally your window goes to 2 pi. From negative 2 pi to positive 2 pi. So you might want to change your window to negative 180 to positive 180 so that you get exactly this look. Okay. Number 24 is a log expression. Now remember with the log of the base is the log of the exponent. Now if you have a calculator that does change of base, you can certainly put this in. You can even do a change of base yourself and do it this way. The log of 1 over 25 over the log of 5. Or you can even say log of 5 log equals exponent. Base 5 to the exponent is 1 over 25. Flip this one over, 25 to the negative 1. Drop them to the same base. 5 to the x is 5 squared to the negative 1. So x is equal to negative 2. If you have the calculator that does the change of base, go right to that one. And you can put it in using your change of base. Number 25 says a 4-digit serial number is to be created from the digits 0 through 9. 4 digits. 0 through 9, guys, has 10 digits to it. It's like your fingers. How many of these serial numbers can be created, so you want a number, if 0 cannot be the first digit, no digit can be repeated, and the last digit must be a 5? Start with this one, must be a 5. There's only one way it can be a 5. Now, no digit can be repeated. So this one cannot be a 0 and cannot be a 5. So now I have 8 choices. Now, out of these, I have 8 left to choose from, then 7 left to choose from, then 1 left to choose from. I would make sure I started at this one. Here's your circle. Find your center of your circle. This is 3, negative 4. Okay, remember your circle formula. And write this down. We see this on every Regents as well. Your center goes in the opposite way. So x minus 3 squared plus y plus 4 squared equals r squared. Start with that and see which ones you can eliminate. We're going for the x minus 3, so anything with the x plus 3, I can eliminate those. Now here's the difference right here. If r squared is 16, then r is 4 exactly. If r squared is 18, then r is a little bit bigger than 4, maybe 4.1, 4.2, whatever the square root of 18 is. And here's your radius. There's up to 4, and it's a little bit more than 4. So it can't be 16. It's got to be the one with the 18 in it. And the last one is a statistics one. Which task is not a component of an observational study? Now remember, an observational study is something in which you observe. You don't give them anything. You don't separate them into groups and give one thing to one and one to the other. In an observational study, you just watch and record. We want to know which is not a component. The researcher decides who will make up the sample. That is true. The researcher analyzes the data. Yep. The researcher gathers the data using surveys or taking measurements, gathers the data. The researcher divides the sample into 2. and one acts as a control group. That means he gives one something and the other nothing. And this is what his experimental does. So this guy is not an observational study because he's giving something to two separate groups. And this concludes part 1.